I'm Karen, and I'm going to introduce you to the problem. So for our problem, we have a bag B being suspended by a string at points A and C. We know a few constants already, such as that the distance between points A and C is going to be 3.5 meters, and that the difference in the heights between point A and point C is 0.75 meters. We also know that the total length of the string, so ABC, is going to be 5 meters, that the constant of acceleration on the bag gravity is going to be 9.81 meters per second, and that the mass of the bag is 100 kilograms. So in order to solve the problem, we need to find the sum of the forces in the x direction and the sum of the forces in the y direction, both of which are going to be equal to 0 since the bag is stationary. The sum of the forces in the x direction are just going to be the cosine components of tension. Since it is just one string, we know that AB and BC have the same tension, and therefore that these two thetas are equal to each other. For the y direction, we have the y component of tension, as well as the force of gravity on the bag. So that's just going to be the weight times 9.81 seconds. And once again, that will also be equal to 0.
Okay, so now that we have our f of net equations, so we have the f of the x component and the f of the y component. Now we can solve for the f of x to find the angle. So here we have the force of the tension of cosine of this angle and minus the force of tension of cosine of this angle, and that should all be 0. So if we solve for them, we can say that this tension AB and the cosine of that angle has to equal the tension of BC cosine of its respective angle. And since we know that tensions have to be equal to each other, because it's a statics problem, we can say that the angles have to be equal to each other, so we can denote them as just theta instead of theta 1 and 2. So we can go ahead and solve our y component equation. So we bring mg over to this side, and we have the tensions of AB and BC respectively. And since we know, again, that the tensions are equal to each other, we can just denote them as tension. So we have two tensions sine of the same angle equal to mg. And now that we have those two solved, we can go ahead and find the actual theta. And to find the theta, we have to take x and solve for it using its components. So x would equal the length of AB cosine of its theta. So we manipulate the equation to find AB. So it would be just x over cosine of theta. And then we do the same for the length of BC. So we have this whole length, 3.5 minus x would have to equal the length of BC, and it's cosine of theta. So when we manipulate that equation, we have BC is equal to 3.5x over its cosine of theta. And since we know that the length of ABC is 5, we can go ahead and set these two equal to 5. So we have this x over cosine of theta, and we have 3.5 minus x over cosine of theta. And we can break this fraction up to call it 3.5 over cosine of theta and x over cosine of theta. So we have two x cosine of thetas that end up canceling out. So we're left with a 3.5 cosine of theta equal to 5. And from here, we can just solve for the angle. So the cosine of 3.5 over 5 would just turn out to be 45.57 degrees.
So going back to our F net y equation, we know that the two tension sine theta is equal to mg. We also know that the mass at the end of the pulley is about 100 kilograms. So Ft sine theta is going to be equal to mg over 2, which is going to be 100 kilograms times 9.8, as we discussed earlier, over 2, which is about 490. So then we can say that Ft is equal to 490 divided by arc sine of 45.57 degrees, which we found down here. And so F of t ends up being around 686.837 newtons. Okay, so to find x, we're going to take our two similar triangles and we're going to assign variables to each of their sides. We know that both of the triangles have a similar angle of 45.57 degrees. So we're going to take the tangent, which is opposite over adjacent. So the tangent of theta for the smaller triangle is going to be y minus 0.75 over x. And we can manipulate that to be x tan theta plus 0.75 is equal to y. And then for the larger triangle, we can say that tangent of theta is equal to y over 3.5 minus x, which then becomes y equals 3.5 minus x times tangent of theta. Now we can set these two y's equal to each other and have similar one variable that we don't know. That's going to be x. So x tangent of 45.57 degrees plus 0.75 meters, which was that one, is equal to 3.5 minus x tangent of theta. And then we can manipulate that to be 1.02x plus 0.75 is equal to 3.57 minus 1.02x. And then 2.04x is equal to 2.82. And then we get x is equal to 1.382 meters.
Alright, to check our work on tension, we can use the equation T sine theta. Plugging in our tension and our angle, we should get 490 newtons. Multiply that by 2 because both tensions are the same. We should get 980 newtons. To check the length of our x, we can use the complement length, which is the length of y. Plug that into the equation y tan theta minus 0.75 meters equals to 3.5 meters minus y times tan theta. And when we do, we should get 1.41 meters. Add that to the length y, which is 2.118 meters. We should get 3.528 meters. So that's a 2.02% error due to rounding. We can also use the inner angles to solve for x.